Welcome to a demo of Honeycomb, the fastest way to visualize, understand, and debug software. In today's product demo, we're going to go over a few things. Incident investigation and response, see if we can understand the performance of our application, and possibly help our developers make better software. Here's a few tips for you while you're watching the demo. First, Honeycomb is query, not search. It's easier and more powerful. Second, ingestion is best done via in-code instrumentation and tracing, but data can come into Honeycomb from a wide variety of sources. You should expect to see sub-second query response time when you're a Honeycomb user, and you have the freedom and flexibility to put data with an extreme high cardinality into Honeycomb. That just means data that has fields with many unique values. In a world of distributed software, distributed tracing is a must. Also, notice my history. Inside of my demo, you'll see the path that I took to find the situation that we discover. So let's go. Our scenario today is an online ticket broker that has an API service for partners to sell and provide tickets for concerts and events and things like that. All the current KPIs and all the other monitoring systems are being met, and all dashboards are green. But someone somewhere is complaining that things aren't what they seem. So let's see what we can find by exploring with Honeycomb. First, when we log into Honeycomb, we see activity. We see boards that I have created as a user, other boards from members of my team, but most importantly, activity that's been happening today inside of this environment. So we have queries being run by me, by Chris, Nathan, and Christine. And having a recognition that we all work together, the goal is to make everybody the best problem solver we can. So in our scenario, I'm going to start with a board that just has a few queries on it for me to get going. And remember, this particular scenario is troubleshooting an API service. So I have one query here that just represents some general activity on this particular data set. And we'll drill in and see the Honeycomb query interface. Before we jump ahead, there are some new things on the screen for you. On the right-hand side, I have details about the data set that we're going to be evaluating. This data is from an API service, so you're going to see some front-end information like HTTP status. You're going to see some back-end timers and other fields that are related to this particular data set. The second tab here that you'll notice will change during my demo is the history. It's kind of like my browser history, but it's every single query that I've ran, and it's instantly retrievable. Third, these gray boxes up here allow me to break down by fields, do mathematical calculations, filter, order, and limit. If we observe our chart, we see a fairly normal pattern of activity. A couple of spikes here and there, but nothing that indicates that there's a problem. Since we have HTTP data, the first thing I'm going to do is break down by status code, and we'll add a mathematical calculation called a heat map, and we're going to run a heat map over the latency of this particular time range. Honeycomb comes back, gives me my chart, and if we notice below, we've broken down by status code. So we've split this into a series by status code, and we also have a heat map. And the heat map is going to show me clusters of events that are happening right around the same time. As we can see, most of our events, most of our requests are much less than 1 second, but we have this periodic spike. Now, most people wonder, where do I go from here? What should I possibly look into, and how do I figure out a problem? Well, at Honeycomb, we have a feature called BubbleUp. BubbleUp is like a brain that you can tap into. So all we have to do is draw a box around an area that we're wondering about. BubbleUp will instantly run analysis on every single field in the data set, and it will show us inliers and outliers. In this case, our teal colors represent what is in the selection, and the dark blue colors represent everything else. When we're looking for a problem, the first thing we have to do is 1, verify that there's a problem, 2, figure out where that problem is exposing itself, and 3, is it affecting a customer? And by BubbleUp analyzing all of these fields for us, we can see, yes, there is a problem. There are HTTP 500 errors. Let's add a filter on that. Second, we can see easily that the main issue is coming from the API ticket export endpoint. Let's add a breakdown by that field. And third, user ID, a high cardinality field, and as we can see, there is one user that's being affected by this spike and this high latency. So we'll also break down by that field. We've added breakdowns automatically and a filter. We'll run that query, and instantly we pinpoint the exact user that is having an issue. Now, if we look closely, user 20109 is responsible for that spike. They're showing up there. They have a high count of hits against that ticket export endpoint that are all showing up as failures. And of course, the latency on that endpoint is now really high. We've found the exact problem in a matter of seconds, but we need to help software developers become better at fixing things. And the way we can do that is by taking a look at a distributed trace. The traces feature in Honeycomb will show us distributed traces across this time range that are of particular high duration. We can examine any number of the traces that appear here. We see our user is being affected plus a few others. We see a span, the summary, each call that is made, and could drill into each one of these if we wanted to. But since we're looking at life from the perspective of the request, I'll go right to that very data point, identify and drill in to the distributed trace for our user 20109, the one that was complaining or experiencing latency. This waterfall chart shows a distributed trace and all of the steps that this particular API request went through to fulfill itself. As we can see, for the ticket export API endpoint, we have that high latency of 1.3 some seconds. On the right-hand side, we see every single field that was attached to this particular request, that 500 error, that particular user on the endpoint, and even the mobile platform that they are using. Now, the process this request takes, it hits the endpoint, a rate limiter is engaged, an authorization service, that happened pretty quickly, and then the ticket backend function starts. And there's a bulk ticket export that happens as a part of this particular request. And as we can see, queries are running sequentially one after another. We can see the query that is being run at each stage and the time that that took. Now, what should we do? We could send this to our development team. Perhaps they could improve the fetch tickets for export function call, but what would happen if they couldn't? If all these queries were supposed to run exactly like this? Then, if a high count of hits on this API endpoint happens, they might improve the rate limiter. But now I've gotten to the point where we understand how the software is behaving in production, under real load by real users. Popping back to the Honeycomb query page, I have some other things that I may want to do. Now, in the course of working on this incident, I need to share what I've found with other members on my team. So I may want to click the share button and post what I found to a Slack channel. Additionally, I may want to add this to my hard-to-find problems board. Next, since this user, 20109, is a high-value partner, it would probably be a good idea for me to keep an eye on latency for this user. In that case, I'm going to use Honeycomb triggers, and Honeycomb triggers allow me to run a query on a periodic basis. Let's go ahead and look at the P95 of duration or latency, where the user ID equals 20109. And we'll run that every 1 minute, and we'd probably like to be notified if the latency is more than 700 milliseconds. In our case, we may choose to send a PagerDuty notification. So in our demo scenario, we started almost with a blank slate, not knowing exactly what to look for and where. And using the speed and intelligence of Honeycomb, we found exactly what was wrong and the experience for that particular user for that request. Lastly, the things that I have done should be usable by others. In fact, I may need to use them myself, so the History tab over here makes all the queries that I have ever done instantly retrievable. But if we see the Activity tab, now every member of the team can look at everything that's been happening on this particular data set and potentially continue the discussion of troubleshooting and observing the services that we're responsible for. Thanks for watching, and I encourage you to go check us out at honeycomb.io.